minus 13x squared plus 36. Who remembers how we come up with our list of possible rational roots? What do we have to do? Ariana? You got it. So we're going to set up P over Q. P is going to be the factors of our constant. So that's going to be plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 12, plus minus 36. Did I get them all? What did I miss? Oh, yes, I missed my 9 and the 18. You're right. So plus minus 9, plus minus 18, then plus minus 36. Now do I have them all? Yeah. 24. No, 24. 12 times 3. Oh, I have 3. I don't have the 12. Sorry, guys. Going too fast here. So let's just see. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. Now we have them all. Okay. So now in our denominator, isn't it going to be factors of the leading coefficient? But what's our leading coefficient? 1. So this is just plus minus 1. It's nice when the leading coefficient's 1. Why? Why is it nice when the leading coefficient's 1?
You don't have to make all the fractions.
We don't have to make all the fractions, so it's essentially just our numerator. So possible rational roots will be plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 9, plus minus 12, plus minus 18, plus minus 36. How many roots should I have? How many should I have? And how do we know? Amanda? Good, we should have 4 roots. Let's just go into Desmos and see. So I'm going to have f of x is equal to, I lost it, x to the 4th minus 13x squared plus 36. Does it look like we have 4 roots? Let's see what we got. Negative 3, was negative 3 part of our list? Yep. Negative 2, is negative 2 part of our list? Yep. Positive 2, we got that. And positive 3, we got that. So all of these roots end up being rational roots. All right. Do you think every problem you'll have Desmos for? No. So now we're going to show what do we do when we don't have Desmos. And I'm asking you to identify which roots are the roots. You ready? All right. So we're going to say to find this. To find zeros using the rational root theorem. We're going to first list all possible rational roots. And that's going to be P over Q. Then we're going to test roots using synthetic substitution, looking for a remainder of 0. Continue synthetic substitution with different possible rational roots until, guys, could you stop talking? You get the function to a degree of 2. Then last step will be to factor or use quadratic formula to find the remaining roots. So, yes.
Wait, wouldn't just like only doing step D give you the roots you need?
Wouldn't only step
Like, I
D?
feel like can't you just use the quadratic as a factor and get all the roots?
You can't, because if I'm giving you something with a degree of 5, you won't be able to use the quadratic on something with a degree of 5, and you're not always able to factor. That's why. Okay, so let's go through this. Has everybody copied down all the steps? All right, let's do our first problem. I'm telling you right now, it is not fun. It is pretty tedious, but it's not difficult. It's just tedious. So I'm going to say find all roots and factors of f of x equals x to the third plus 3x squared minus 6x minus 8. Okay, so your first step is P over Q. Find your list of possible rational roots. So possible rational roots. Now, do we agree that the denominator is going to be 1? So do I even need to make a denominator if I know it's going to be 1? So now all I need are possible factors of 8. Not too bad, right? Plus minus 1, plus minus 2, plus minus 4, plus minus 8. How come I didn't make a denominator? You got it. Because the leading coefficient is 1, so it would essentially just be the factors of 8. So we don't need to make the fractions. All right, so now what we're going to do, and this is where it's your luck. We're going to take one of these possible rational roots. We don't know which one's going to work. It's us and our lucky guess. So choose one possible rational root. Give me any number from this list. 1. Let's go with 1. And now we're going to test 1 out. We're going to see, is 1 really a root by using synthetic substitution? So I have every exponent accounted for, so I'm just going to list out my coefficients. Bring down the 1. 1 times 1 is 1. 3 plus 1 is 4. 4 times 1 is 4. Negative 2 times 1 is negative 2. Negative 10. Is 1 a root? No, because the remainder is not what? 0. So 1 is out. All right, so now we got to try again. Pick a different one. Let's go with 2. So now I have 1, 3, negative 6, negative 8. Bring down the 1. 1 times 2 is 2. 3 plus 2 is 5. 5 times 2 is 10. Negative 6 plus 10 is 4. 4 times 2 is 8. Negative 8 plus 8 is 0. Does this one work? Yes. So what does that tell us? That tells us that x equals 2 is a root. And what would be the factor that goes with x equals 2? Charlie?
X minus 2.
You got it. Now you just set this equal back to 0. So it's going to be x minus 2. So this is one root. This is one factor. Are we good so far? Okay. Now, how many roots do I have? Or should I have? 3 roots. Now, every time we do the synthetic division successfully, doesn't it decrease the degree of the polynomial by 1? So now my new coefficients here are going to be x squared plus 5x plus 4. So now that I've gotten the polynomial down to a degree of 2, I'm not guessing check synthetic anymore. Once I get it down to a degree of 2, I can either factor or use a quadratic equation. Can I factor this? Yeah, if we factor this, it's x plus 4, x plus 1, which gives us roots of x negative equals negative 4 and x equals negative 1. So now we're going to list our roots are going to be x equals 2, negative 4, negative 1. That's part of the answer. What was the other part of the answer? Factors. So our factors are going to be x minus 2, x plus 4, x plus 1. It's a little bit different. We'll do more. Don't worry. Anybody still copying this? We're okay? All right, next one. So again, I want to find all roots and factors. And this time I have g of x is equal to x to the 4th plus 10x cubed plus 33x squared plus 38x plus 8. All right, how many roots or solutions will we have? 4. So that means I need to do the synthetic division or synthetic substitution successfully how many times? Twice. Because if the degree is 4, that means I need to get it down to a degree of 2 so I can then use the quadratic equation or factor it. So in order to get it down to a degree of 2, I need 2 successful synthetic substitutions. So to start, we're going to do our P over Q, possible rational roots. And again, do we agree our denominator would once again be 1 since our leading coefficient is 1? So now this is only factors of 8 once again. So we're going to have plus minus 1, plus minus 2, plus minus 4, plus minus 8. Okay, little hint here. Do you see how everything is a plus sign? So in order to get to a 0, do you think any of the positive numbers will work to get us to a 0? No, because a positive times a positive is a positive. A positive plus a positive is still a positive. So we're just going to keep getting bigger and bigger and bigger if we're using positive, since everything is a plus sign. So my focus is on the negative numbers. Choose a number to guess to start with. -2, let's try it out. So I have a 1. Every exponent is accounted for, right? 4, 3, 2, 1. Yep. So we have a 1, we have a 10, 33, 38, and 8. 1 times -2 is a -2. This gives us 8. This gives us a -16. This is going to give us 17. This gives us a -34. 4, -8, 0. Was -2 successful? Yeah. So what does this mean? This means x equals -2 is a root. And what's the factor that goes with that root? X plus 2. You got it. All right. How many more times do I need to find a root that works? One more time. But am I going back to the original problem, or do I use my new coefficients? You use your new coefficients. So now my new coefficients, I'm 1 degree less. So now we're going to have x to the third plus 8x plus 8x squared plus 17x plus 4. Again, isn't it all positives once again? So the number I'm going to put in the box, shouldn't it be negative? What number do you want to guess this time? Sure, let's try a -4. So we have a 1, an 8, a 17, and a 4. 1 times -4 is -4. 8 plus a -4 is 4. Got a -16, and then a -4. And you guys are good at guessing. So what does this mean this time? This time it means we have a root of x equals -4. And what's the factor with that? X plus 4. So now, since we've had 2 successful runs with synthetic substitution, we've now brought it down to a degree of 2. So this is x squared plus 4x plus 1 equals 0. Can I factor this? No. Since I cannot factor this any further, when I ask for the factors, our factors are going to be x plus 2, x plus 4, and then this whole trinomial, x squared plus 4x plus 1, since I cannot factor that any further. But I still need the solutions that go with x squared plus 4x plus 1. And since I can't factor it, what should I use? The quadratic formula. So now we're going to have x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to get x is equal to -4 plus or minus the square root of 12 all over 2. I can simplify the square root of 12. So x equals -4 plus or minus 2 root 3 all over 2. Can I pull out a 2 and cancel out that denominator? So then we're going to have -2 plus or minus root 3. How many solutions does this count as? 2. So now we wrote that our factors, now we want to find our roots. So now our roots are going to be x equals -2, -4, and -2 plus or minus the square root of 3. Okay, next one. I actually want to see how you guys do this one on your own. So try this one on your own. How many solutions should we have? 4. Good job. Is there any tweaks we need to make once we get to the synthetic? Yeah, what tweaks do we need to make once we get to the synthetic portion? Ariana? You got it. We're missing 2 exponents here. We're missing to the 3rd power, and also aren't we missing to the 1st power? So if we wanted to write from the beginning, you could write it as f of x equals x to the 4th plus 0x cubed plus x squared plus 0x minus 2. Now it's in a good format for synthetic. So once again, I want you to find the factors and the roots. Okay, let's look at this. So, possible rational roots is really nice because there's not many options here. We have plus minus 1 and just plus minus 2. How come there's no denominator? Because the leading coefficient is 1. All right, so I need to have a successful synthetic substitution how many times? Twice. So what was the first number you guessed? Anybody? Leo? 2. Let's go with 2. Were you successful with the 2, Leo? I would say no. Was anybody successful with anything? 1 worked out. So let's do the 1. So we have a 1, a 0, a 1, a 0, and a negative 2. Bring down that 1. 1 times 1 is 1. 1, 2, 2, 2, 2, 0. There we go. So 1 was successful. So what does that mean? For our roots, we're going to have x equals 1. And now we're going to use the new coefficients, 1, 1, 2, 2. And now I need to guess another one. We should guess a negative 1. That's going to work. So we have a 1, negative 1 is 0, 2, negative 2, 0. So what does that mean? Our next root is x equals 1. Then we had x equals negative 1. Because I've had it successful twice, doesn't that now bring me down to a degree of 2? So now I have an x squared plus 0x plus 2 equals 0. Do I need to put the 0x? No. Can I factor this? No. Can I use the quadratic formula on this? Does that make sense? No, we just solve. X squared equals negative 2. To undo a square, what do we take? Square root. What's going to happen here? It's imaginary. X equals plus or minus I root 2. So we have x equals 1, we have x equals negative 1, we have x equals plus or minus I root 2. Isn't that 4 solutions right there? So now I didn't only want the solutions. What else did I want? The factors. So we're going to have x plus 1, x minus 1, and then the factor that gave us I, wasn't this the factors that gave us I? So then the last one is x squared plus 2. We good? All right, last one. This one's not as nice. Why is this not as nice? We have denominators now, right? So we're going to have fractions. So our P over Q, possible rational roots, are going to be plus minus 1, plus minus 2, plus minus 5, plus minus 10. And our denominator is going to be plus minus 1, plus minus 2, plus minus 4. Now what we do is we mix every numerator with every denominator. So P over Q is going to be plus minus 1 over 1, which is just 1, plus minus 1 over 2, plus minus 1 over 4. So the first numerator with every denominator. Now we're going to do the second numerator with every denominator. So plus minus 2 over 2, but that's just 1. And then plus minus 2 over 4, but isn't that just a half? So I don't need to write those down again. Then we have plus minus 5 over 2, plus minus 5 over 4. Then we go on to 10, plus minus 10. 10 over 2 is 5. We already have that. And 10 over 4 is 5 halves. We already have that. So these are our possible rational roots. Now, luckily, it's a degree of 3. So how many do I need to find to make this work? Just 1. If I just find one possible rational root that makes it work, then it brings it down to a degree of 2. Then I could factor or use the quadratic or whatever it is. I will tell you, negative a half is going to work. So I'm going to use the negative a half for negative 16, 11, and 10. What's half of 4? 2. So this gives us a negative 2. Negative 16 plus a negative 2 is a negative 18. What's half of 18? 9. So that's a positive 9. 11 plus 9 is 20. Do we all agree half of 20 is 10? So that's a negative 10, and there's our 0. Not as bad, right? Because I found one successful root that now has brought us down to a degree of 2. So this is going to be 4x squared minus 18x plus 20. Can I pull out a GCF of 2 here? Not a 4. Can I pull out a GCF of 2? So then we're going to have 2x squared minus 9x plus 10. And I will tell you, we can factor this. We're going to have a 2x minus 5 and an x minus 2. Two cannot equal 0, so that's out. We're going to get 2x minus 5 equals 0 when x is 5 halves, and x minus 2 equals 0 when x is 2. So doesn't it turn out that actually all the roots are rational roots and they were all part of the list? So it wasn't only just the negative half that worked. If we would have started off with the 2, that would have worked. If we would have started off with the 5 halves, that would have still worked. So now our roots will be x equals negative a half, 5 halves, and 2. And our factors, this one takes a minute. We're going to have the 2x minus 5, and we're going to have the x minus 2 from right above, right, that we just factored. But be very careful. The other root was x equals negative a half, right? We're not going to just add that over and make this x plus a half. We're not going to do that. What you're going to do, since it's a fraction, you're going to do step by step. First, you'll multiply the 2 on both sides. So that's a 2x equals negative 1. And then what are you going to do? Add that 1 over. So it's 2x plus 1. So a 2x plus 1 gives us that factor of negative a half. Ariana? No. All right, we are done.